Hi everyone, welcome to Java Techie. So in previous tutorial, we have developed a Kafka producer application where we have produced bulk messages to the topic, and also we visualized how the messages are being distributed to multiple partitions of a topic, right? So in this tutorial, we will design a consumer application who will consume messages from the topic, and apart from that, I will also demonstrate how the consumer group works in Kafka. Okay, alright. So without any further delay, let's get started. So when your producer application will produce the messages, it needs to consume by the consumer. Otherwise, by keeping the messages in a topic without using it does not make any sense. So you need to write a consumer app who will consume the messages from your topic. Now if you observe in the flow, one consumer is listening to three different partitions, which is not good. I mean, it don't give you the better throughput. Then how can we design our consumer app to overcome this issue? It's very simple. Just share the workload to multiple consumer instance. So what you can do, we can simply create multiple consumer instance and then we can group them with an unique ID so that this ID will indicate the task of a specific consumer group. So now if you observe, we have three consumer instance, right? And how many partition do we have? Three. So each partition can consumed by individual consumer instance, which will definitely increase the throughput. Earlier, a single consumer instance is pointing to multiple partition. Now we have a individual consumer instance for each partition of our topic. Definitely, this will give you the better performance. But what if I have another consumer instance? Then what he will do? Because already three partition is being assigned to three consumer instance. Then what the fourth consumer instance will do? Nothing. He will simply stay on bench. The way IT company hires the employee and keeping them in a bench for future project, and once the project came, they assign the employee, right? Similarly, if any consumer instance dies, then this consumer 4 will replace that and start consuming the messages, and this concept is called consumer rebalancing. Okay, so this is what all about the theory of Kafka consumer on the basic level. So we understand the theory. Now let's start implementing our consumer app to understand this practically. Okay, so let's go to the IntelliJ IDEA. So this is the Kafka producer example we have tried last time. Now let's quickly create a Kafka consumer application. Click on File, New, click on Project, click Next, then specify all the required field. Now let's add all the required dependency. I will just add Kafka, Spring for Apache Kafka, and then I will just add web dependency, Spring Web. That's it. Click on Next, click on Finish. So now we have created the consumer application. Now if you observe here, consumer application is the one who connect to the Kafka topic to receive the messages. So you need to tell to your consumer application where is your Kafka server up and running. Then only he can connect to the topic and he can retrieve the messages, right? So first step, you need to tell to your consumer where is your Kafka server is up and running. So go to the resource or application.properties, it is up to you. I am using the application.yml file. Now here you will define Spring, Kafka, then consumer, and where is your bootstrap server is up and running. In our case, it is running on port localhost 9092. Make sure before you start your producer and consumer, you should start your zookeeper, then your Kafka server. Okay, and also I will just change the server port here. Server port 9292, because I believe my producer is up and running on port 91. Okay, 9191. So I just change it to the 9292. That's it. Now let me quickly create a package so that we can start creating a class who will do the actual logic or who will try to fetch the messages from the topic. Okay, let me create a package. Then we'll create a class. Now just annotate this class with @service. Fine. Now we'll write a method who will do the actual logic to retrieve the message from the topic. Public void. So what I'll do, I need to annotate here @sl4j. Okay, I didn't add the lombok. Fine. I'll create the logger object. Then complete the method. Consume. That's it. Now which type of data we are sending from the producer? If you go and check in your producer, go to the class, we are sending message of type string, right? So you need to specify the type, what messages this method will consume. So I'll specify string message. Fine. Now I'll just add the log statement to print that messages. Logger, or just change it to the log. Just add some messages. Okay. Consumer consume the message and the messages we are receiving. Fine. We are not doing anything. We are simply write a method to consume the message and we are just simply printing them. Now, how this consumer will know from which topic he need to read the messages, that you need to tell to the consumer. Okay. How you can tell that? Simple. The annotation is Kafka listener. Now in this Kafka listener annotation, you can tell to the application, or you can tell to this consumer who is the topic from where you want to read the messages. Okay. So in our case, what is the topic we created in our producer application? Java Techie demo, right? We are creating the topic in our config class. This is where we are creating the topic with 3 partition. So you need to specify the same topic name in consumer from where you want to listen the messages. Now all good. Let me start the producer, then we'll start the consumer app. So go to the producer, start it. Once it will up, we'll start our consumer. So producer is up on port 9191. Now let me start the consumer app. Go to the main class and simply start it. Meanwhile, I will open the Postman. Let's check the producer code in our application. Just go to the publisher. Not here. Go to the controller. Just wanted to check how many messages we are publishing. Okay, 10,000, right? That's fine. We can send the 10,000 and we'll see whether it is getting logged in our consumer or not. Then we'll change it. So we'll go and check our consumer app. We are getting the error. Now if you observe carefully, the error clearly says that no group ID found in consumer config. As I already explained, even though you have a single consumer instance, still you need to map it to a consumer ID. But in our code, we have not specified any consumer ID. Okay, that is the reason Kafka is giving error. Hey, just map a group ID to your consumer instance. So if you'll define group ID here, group ID, and let me give something like Jetty hyphen group hyphen 1, something like that. Okay, and also I need to configure this particular group ID in YML file or application.properties file as well. Okay, because that is the central place where we are specifying our configuration. So Spring. Okay, so already we have defined this. So in the consumer section only, you can define group ID. What is the group ID? Jetty group 1. This is the group ID we have created. You can give any unique name. Okay, it will just help you to find the role of your consumer group, or to find the role of your this particular consumer group, which task it is doing. That is the reason you can segregate using this consumer or group ID. Okay, that's fine. Now go to the listener. We have defined the same and we have defined same in our config. Now let me restart it again. So consumer app is up and running. Now if you observe carefully, let me zoom this for you. Jetty hyphen group hyphen 1 is my consumer group ID, right? This particular consumer group is assigned to all the three partition. Can you see here? Java Techie demo 0, demo 1, demo 2. The Java Techie -demo is my topic name and partition name append with the number 0, 1 and 2, and all the three partition of my topic is being assigned to single consumer instance by specifying this particular group ID. So that is what the first step we have discussed here. A single consumer instance is trying to read from multiple partition. This is the happy scenario what we are trying now. Later we will increase the consumer instance and we will see whether the each consumer instance is pointing to each partition or not. That is the next step. Okay. Now for now you can read this particular statement to understand. This is the consumer instance and this is the group ID is being assigned to all three partition. That's fine. Let me clear this. Go to the postman. Let me send the message. It will send 10,000 messages, right? It will definitely take few seconds. Message published successfully and it take 1507 millisecond. And now let's check in our consumer app. Can you see here? Consumer consume the message, user this one. I mean this is the message, this is the message, and this is my log statement. Consumer consume the message, this. All the 10,000 messages is being consumed. Okay. Now how you can sure that all the 10,000 messages what you have published from producer is being consumed by your consumer? Simply go to your offset explorer, then refresh the topic. You will find the Java Techie demo as a topic. Now let me refresh this. Yeah, you can see here, right? This is what our topic and this is what the consumer group we have created. Now first let's verify the data in topic. So just run it. Now if you will go and check in the Java Techie demo, go inside the partition, you can verify each partition, getting the messages. Partition 0 received 5150, partition 1 received 2346, partition 2 also received something 2505. I mean all the three partition received the messages. Okay. Now if you'll go and check in the consumer group, if I will open the offset, can you see here the topic name is Java Techie demo and message received to all the three partition 102. Okay, and count of each partition messages, each messages in partition, you can see your partition 1 is this much, 0 is this much, and 2 is this much. Now offset is the number of your sequence. Now if you observe your lag is 0. Now all the partition, whatever the messages they have received, they are able to deliver that messages to the consumer. I mean consumer successfully read 2346 messages from partition 1, 5150 messages from partition 0, 2005 messages from partition 2. That is the reason you can see the lag count is 0. There is no message is pending from your producer side to consumed by your consumer. All the messages whatever your producer is published is being consumed by your consumer. Okay. So by seeing this lag number, you can understand how many messages your consumer is not received. Okay. This is what I always prefer to use this offset explorer, because this will give you the lag information. Okay. That's fine. Now what do you understand? Partition 0, 1, 2 received all the messages, but we have only one consumer instance who is listening to these three partition. Now can we try creating three consumer instance so that we'll verify whether all the three instances is pointing to individual partition or not? We'll do that right away. Let's go to the code. You can create a separate class and define the this particular Kafka listener, and you can specify from which topic you want it to read, but we'll simply create duplicate method to consume the messages, okay, rather than create duplicate class. So I'll just copy the messages. I'll create three consumer instance. Okay, let me zoom this for you. This is the second one, so I'll just define 2. I'll define 1. Now I created another one. This is 1 2 3, right? we have created 3 consumer instance. Also, as per the flow I explained, right, if there is a fourth consumer instance, then what he will do? Because we have 3 partition, all the 3 partition will assign to each and every consumer instance. Then what is the role of consumer 4? We'll see that as well. Okay, so we'll create another consumer instance for backup. So I'll name it anything. You can give consume 4. That's it. Now I'll just change the log statement, otherwise it is difficult for us to filter out who received the messages. Okay, so I'll just define this is consumer 1, consumer 2, consumer 3 and 4. That's it. Okay, group id everything is same. We have just created multiple consumer instance. So we'll see messages will come to, if messages will come to 2 partition, then 2 consumer instance should read those messages from the partition. It can be consumer 1 and consumer 2 or 3 and 4, any order. That is depends on the zookeeper coordinator. This is not in our hand. That's fine. So for safer side, what we'll do, we'll just change the topic name and group id. Okay, I'll change it to the group Jetty group. Same I'll replace in all the method. Also I'll change the topic name. Same I need to do the change in my producer as well, right? So producer will publish the message here and also in config, right? That's it. So we have created the same 3 partition. Let me restart the producer. Producer is up. Now let's go and start our consumer. Now if you see the statement, consumer is up and running. 3 individual consumer instance is being assigned to individual partition. You can see here, right? Our topic name Java Techie demo 1 -1 -2 0 is nothing your partition number, and it is just giving the group name because we don't specify our consumer instance name. All the consumer instance we are wrapped inside a group id. So you can see instance 1, instance 2 and instance 3 is pointing to 3 different partition from the topic. Now let's verify that right away. Okay, clear it. I'll send the request. Now my producer will publish 10,000 messages to the topic, and the messages will distribute to 3 different topic. Okay, now then we have 3 consumer instance. We'll see whether all the messages is being distributed to individual partition and consumer instance combination or not. So go to the postman, simply hit the request. It published the 10,000 messages. First let's verify how many partition received the messages. Okay, then based on that we'll validate our consumer instance. Go and check here. Let me refresh the topic. Also let me refresh my consumer. We have the new consumer Jetty group. We'll verify here only. Okay, partition 1 to 0, all 3 partition receive the messages. There is no lag. It means there should be 3 consumer instance log statement we can see. Okay, if you are not seeing 3 consumer instance log, then our concept is wrong, what we discuss is wrong. Okay, so let's verify it right away. So how we can filter it? Simple, right? That is the reason I have changed the first statement. So I'll just filter here. Consumer 1 received 2445 messages. Now we'll see who else received the messages. Does consumer 2 receive? No. Consumer 3? Yes. Consumer 3 received 2371. Okay. Now we'll see consumer 4 also received something. Yeah. 2176. So what we cleared here? We have 4 instances. Consumer 1, 2, 3, 4. Consumer 1, 3 and 4 receive the messages. You can see in 4 we can see some messages, right? And the count you can see here. Now if we'll change it to the 3, consumer 3 also receive the messages, right? Now if we'll change it to the 1 also receive the messages, but 2 consumer is not receive the messages. Okay, consumer 1, 3 and 4, only these 3 consumer instance receive the messages, not this guy. Why? Simple statement, right? We have 3 partition, that is the reason it assigned to the 3 consumer instance. 1 consumer instance 2 consumer instance, 3 consumer instance. If message is being pushed to only two partition, let's say partition 1 and partition 2, then only two consumer instance will print the statement. That is how the Kafka maintain the balance between the partition and consumer instance. Okay, now what I'll do, the order is not same, right? Now this time consumer 2 didn't receive the messages, but there is no guarantee that when the message will come next time consumer 2, 3, 4 or 1, 2, 3 like that, anyone can receive it. Okay, we'll just verify it right away. Now I'll again send 10,000 messages. Fine. Now we'll see who are all received the messages. Consumer 3 received the messages. Fine. Consumer 2, no, it didn't receive. Consumer 1 received. Consumer 4 received. Okay. If we'll try many times, there might be, you can see the change in order. Okay. It can be 1, 2, 3 or 3, 2, 1, any order. We can't predict it. It will be decided by coordinator. That's fine. So I believe you are pretty clear with this concept. Okay. Number of partition we have, number of consumer instance, make the mapping and get the messages. That is the simple statement. Okay. But just keep a note, in real time you should not write multiple consumer instance like this. Okay. So this is just, I give you the demo to give the clear picture about this partition and consumer instance mapping. In real time, you can make it in a better way by implementing the concurrency. So you can design or you can increase the throughput of your application. Okay, just keep a note again. This is just for the demo purpose. So you should not write the code like this in your consumer. That's fine. Now let's understand, if I have published 10,000 messages to the topic, whether all the messages is being consumed by my consumer or not. Let's say producer published the 10,000 messages, but in between my Kafka consumer is shut down. Then that time, how can I verify that how many messages my consumer received or how many messages he didn't receive? That is what the lag we just discussed now, right? But let's prove it. I mean, we'll forcefully stop our Kafka consumer and we'll validate how the lag show the exact behavior or not. Okay, or whether it shows the exact number or not. Fine. So what I'll do, I'll just open my Postman. So I'll keep this in two different section so that I can quickly stop my consumer. Okay, cool. So let me clear everything. I'll send the request, then immediately I will stop it. I don't know how many messages is being published, because from the producer we have published the 10,000 messages. Okay, so the topic name is also same. Let's verify it right away. Go to the Offset Explorer, just reconnect it, open the topic Java Techie demo 1, go into the partition, but it won't give you any clue here. If you look into the topic, better you go to the consumer. There is no lag because we are not able to shut down immediately. Okay, so what I'll do, I'll publish more messages so that I will get enough time to shut down my consumer. So I'll go to my producer application, then this is how many, 10,000, right? I'll send 1 lakh messages, and also I'll just change my topic name. Go to the config here. Okay, we did change in config, change this topic name. Now go to your consumer code. I mean, meanwhile, let me start my producer, right? We have did the changes, just restart it. I'll go to the consumer. In consumer also, you need to change the topic name. Let's say 2 only, right? And I'll change the group, Jetty group hyphen new. Let me specify in all the instance. Fine. We have changed the consumer group and we have changed the topic name in both producer and consumer. And we start our producer. Now let me start my consumer. Okay. Consumer is up and running. Let me clear everything. Let me send the request now. Now it will send 1 lakh record to the Kafka. Okay, now send the request, and meanwhile I will stop it. I'm able to stop or not, I'm not sure, but I've tried it. But let's see. I will just reconnect it, okay, so that it will refresh everything. Go to the topic. This is the topic newly we created, right? Go to the consumer, Jetty group new is there. Yeah, we are able to deliver it. Java Techie demo 2. Can you see here? Not don't verify the demo 1. This is the recent topic we created. In demo 2, partition 1, it received 32,358 messages, and only 976 message is being consumed by your consumer. That is the reason you are able to see the offset count. Rest 31,382 messages is not being consumed by your consumer. Okay, you won't find those messages in your consumer section. Okay, now if you'll see the partition 0, it received 32,766 messages. It was able to deliver 3,217 messages. 29,549 messages is not being consumed. Producer is able to publish the messages, but somehow your consumer is shut down that time, so he is not able to receive those messages. Okay, now you can easily identify, right, which partition is don't I mean which partition messages is not being consumed by your consumer. So in real time, in production issue, you might need to republish your messages, or you need to publish your messages again to resolve such kind of issue. So if you have this tool, at least you can figure out, right, the number of messages in which partition. Okay, that will give you the clue, and you can publish the messages from that specific partition. Okay, and you can see here partition 2, 34,000 messages he received, but he only published 3,257, because these are the messages is being consumed by consumer. 31,620 is not consumed. Okay, so this is how you can figure out the lag in your producer and consumer. So it will make your job easier, or it will give you the better productivity while analyzing the issue on Kafka. Okay, don't worry, I will also tell you in my upcoming tutorial how you can retrieve a specific messages from the partition. We'll go in deeper, okay, with the code in my upcoming session. So I hope you are clear about the consumer and consumer instance and partition mapping, and how to verify the lag in the Offset Explorer 2. So do let me know in a comment section if you guys have any doubt. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.